Bismillahirrahmanirrahim. Today is lecture 21 of the Artificial Intelligence course. In our day-to-day life, we might face situations where we are unable to determine whether the state is true or false. As a human, we usually rely on common sense when we want to solve different problems. We also use vague and ambiguous terms. Fuzzy is a logic that refers to something which is unclear or vague or uncertain. Fuzzy logic in the artificial intelligence provides valuable flexibility for reasoning. And in this lecture, we'll learn about this logic. So in today's agenda, we'll discuss on the fuzzy logic. We'll differentiate between crisp and fuzzy sets. We'll also learn about linguistic variable and membership function. We'll discuss on fuzzy logic system, which is actually the architecture of the fuzzy logic system, and we'll list out some of the applications of the fuzzy logic system. So what is fuzzy logic? Fuzzy means unclear, and logic is a process for making a conclusion, or we can say it is a study of the principles of correct reasoning. According to Wikipedia, fuzzy logic is a form of multi-valued logic derived from fuzzy set theory to deal with reasoning that is approximate rather than precise. Cambridge Dictionary defines fuzzy as a theoretical system used in mathematics, computing, and philosophy to deal with statements which are neither true nor false. Fuzzy logic is a method of reasoning that resembles human reasoning. The approach of fuzzy logic imitates the way of decision making in humans that involves all intermediate possibilities between digital values yes and no. Crisp values are the classical traditional set. Crisp set theory is governed by a logic that uses one of only two values, true or false. This logic cannot represent vague concepts and therefore fails to give the answers on the paradoxes. Crisp variables present precise quantities, that is, any value of x. It is precise. It is an accurate value. This is a crisp value. A may be 0 or 1. A proposition is either true or false. This is a logic. A and B implies C. So this statement may be either true or false. This is a proposition which can be either true or false. Richard is a king and Richard is greedy. This implies that Richard is an evil. So this is again a proposition which may be either true or false. There is nothing in between the two. So this means that if Richard is greedy, so the value may be 0 or 1. This statement may be either true or false. Consider these roses. A rose is either red or not red. Here only one rose satisfies the condition. Or we can say one rose belongs to red set and hence its value of membership function is 1, while others do not belong to the red set and their value is 0. So what about this rose? This rose is neither red nor white. We cannot clearly distinguish this rose, as therefore cannot put this in the category of red roses. A fuzzy set is one whose membership function can have any value between 0 and 1. The value of the function then is a measure of the degree of membership in the set. That is how much an object belongs to one set and to the other set. So there must be some membership degree to which the object belongs to a set in fuzzy logic system. In the classical or Boolean logic, truth values 1 represent absolute truth value and 0 represent absolute false value. But in the fuzzy system, there is no logic for absolute truth and absolute false value. The basic idea of the fuzzy set theory is that an element belongs to a fuzzy set with a certain degree of membership function. Thus, a proposition is not either true or false, but may be partly true to any degree. See this diagram. It shows that in crisp logic, one of value will be true for is it cold? Is it cold? So it may be yes or no. So this means that the membership function will be either 0 or 1. But in the fuzzy logic system, there are linguistic variables present like very much, little, or very. These linguistic variables can be represented by degree of membership in the fuzzy logic, whose values can be in between 0 and 1. So there are no crisp 0 or 1, and these variables have values in between 0 and 1. Consider another example. Let's suppose there are students in a class. So we can say that all the students make the universe of this course, which is X. Who does have a driver license? So there may be few students who have licenses and others do not have. So there are crisp values of zeros and 1, where 1 is for having the license and 0 they do not have, license. But when the students are asked who can drive very well, so they cannot answer this in crisp values of zeros and ones. Rather, they will define their expertise in degree form, that may be in between 0 and 1. Some cannot drive at all. There are some drivers, they have just started, like this one, and some are expert in driving. So there is a membership degree that, so this cannot be defined in the crisp set and can easily be handled with the fuzzy logic system. So fuzzy logic is a superset of conventional or Boolean logic that has been extended to handle the concept of partial truth and truth values between completely true and completely false. The classical example in the fuzzy set theory is the tall man. This is another example. We say Tom is tall because his height is 181 centimeter. Let's suppose we draw a line here and we say all the men above this height are tall and less than this are short. So we would find that David, who is 179 centimeter, is small in the crisp set, as he is as the line we just drawn is of 181 and David is 2 degrees less than that. So in the crisp set, David got 0. A fuzzy set is capable of providing a graceful transition across a boundary, as can be seen in this figure. The horizontal axis in this figure represents the universe of discourse, or you can say the range of all possible values applicable to a chosen variable. In our case, the variable is the human height. So according to this representation, the universe of men's height consists of all men. The vertical axis in the figure represents the membership value, which is in between 0 and 1. In case of crisp or Boolean logic, a line is drawn at 180 centimeter that indicates that 180 and above 180 centimeter are heighted people and their degree of membership function is 1, while below 180 centimeter all men are considered not tall and their degree of membership is 0. So we can see that David, who is 179 centimeter tall, which is just 2 centimeter less than Tom no longer suddenly becomes a not tall man. Now David and other men are gradually removed from the set of tall men according to the decrease of their heights. Fuzzy logic reflects how people think. It attempts to model our sense of words, our decision making, and our common sense. As a result, it is leading to new, more human intelligent systems. Fuzzy logic system. Fuzzy logic was initiated in 1965 by Lotfizadeh, a professor a professor of computer science at the University of Berkeley. Fuzziness rests on fuzzy set theory, and fuzzy logic is just a small part of that theory. However, Zadeh used the term fuzzy logic in a broader sense. Fuzzy logic is determined as a set of mathematical principles for knowledge representation based on degrees of membership. Unlike two-valued Boolean logic, fuzzy logic is multi-valued. We have we have values in between 0 and 1 and not the crisp. It deals with degrees of membership and degrees of truth. This is the paper that was first written by Lotfizadeh. Fuzzy sets, the Journal of Information and Control. Until today, it was cited 95,755 times. Let X be the universe of discourse and its elements be denoted at X. In a classical set theory, an element X in X may belong or not belong to a set A. The crisp set A of X is defined as the characteristic function of A. So it may belong to the set, X may belong to a set A or not A. And f of Ax is called the characteristics function. A classical set theory imposes sharp boundary because of these absolute values. This set maps universe X to a set of two elements. For any element X of universe X, characteristic function is equal to 1 if X belongs to A and is equal to 0 if X is not an element of A. Unlike a classical set, a fuzzy set is expressed. A fuzzy set expresses the degree to which an element X of X belongs to a set. Hence, in a fuzzy set A, each element has a crisp degree of membership function in the interval or in the range between 0 and 1 and is defined by the membership function of set A. This is the membership function of set A. This set allows a range of possible choices. For any element X of universe X, membership function equals the degree to which X is an element of set A. This degree, a value between 0 and 1, represents the degree of membership, also called membership value of element X in set A. By all this, we mean that an element belongs to a fuzzy set with a certain degree of membership. A fuzzy set can be simply defined as a set with fuzzy boundaries. Fuzzy linguistic variables. At the root of fuzzy set theory lies the idea of linguistic variable. A linguistic variable is a fuzzy variable. For example, the statement John is tall implies that the linguistic variable John takes the linguistic value tall. This is a variable and tall is its value. A linguistic variable having a range of possible values represents the universe of discourse of that variable. For example, the universe of discourse of the linguistic variable temperature might have range between 0 to 100 and may include a set of linguistic values as freezing, cool, warm, hot, are very hot, and so on. Each fuzzy subset also represents a linguistic value of the corresponding linguistic variable. In fuzzy expert system, these linguistic variables are used in fuzzy rules. And if the rules consist of antecedent and consequent part, where each having an object and its value. That object is actually a linguistic variable and the value is the linguistic value. For example, if wind is strong, then wind is strong is an antecedent where wind is a linguistic variable and strong is its linguistic value. Then selling is good. Selling is the consequent where again selling is the linguistic variable and good is its value. Similarly, if speed is slow, then stopping distance is short. Speed and stopping distance are linguistic variable and slow and short are its values. A linguistic variable carries with it the concept of fuzzy set qualifiers called hedges. Hedges are terms that modify the shape of fuzzy sets. They include words like very, somewhat, quite, more, or less and slightly, etc. Like Sean quite like Thai food. Mary looks very much like her mother. Sami has been to several attraction places in Pakistan. Here, quite, very, and several are known as hedges, and they are used to modify the shape of fuzzy sets. Okay. So we already know that fuzzy logic is not logic that is fuzzy, but logic that is used to describe fuzziness. This fuzziness is best characterized by its membership function. In other words, we can say that membership function represents the degree of truth in fuzzy logic. A membership function for a fuzzy set A on the universe of discourse X is defined as a membership function whose values are in the range between 0 and 1. Membership functions allow you to quantify linguistic term and represent a fuzzy set graphically. For example, if we say temperature is a linguistic variable, then it can be represented graphically where freezing, cool, warm, and hot are its fuzzy values representing some crisp values. These are linguistic values and these are its script values. So freezing can be started from 10 to 50 Fahrenheit. Similarly, cool values may be in the range of 30 to 70. Warm values can be in 50 to 95 Fahrenheit, and hot uh, range start from 70 to 110 or and so on. So this means that this is the linguistic variable, and this is its linguistic values having range of possible values. Now let's suppose we want to know how cool is 36 Fahrenheit. To know this, we draw a line on 36 Fahrenheit. Now the line crossing the fuzzy membership function are the points that shows the degree of membership function of temperature 36. So it is 30% cool and 70% freezing. The membership functions play a vital role in the overall performance of fuzzy representation. Among numerous forms of fuzzy membership functions, three shapes are commonly used, that are trapezoidal, triangular, and Gaussian. In previous example, we have used triangular membership function. Let's consider an example. People are distinguished using their age in groups of young, middle, and old age. Using fuzzy sets allow us to incorporate the fact that no sharp boundaries between these groups exist. We cannot say that young people start from this age until this. Similarly, we cannot say that middle-aged people start from this. So there are some ranges in which the young people are considered, and the ranges in which the people are considered middle-aged, and above some um, range the people are considered old. So the linguistic variable age is described through three linguistic values, namely young, middle-aged, and old. Let's suppose a person P with age 4 belongs to both groups, young and middle age. If we draw a line here, a 24, so this line is crossing both the young and middle-aged line. So the person is 0.6% young and 0.4% in the middle age. With an increase in the age, as the age increased, the degree of membership to the group of young people will decreases, whereas the middle-aged increases. The main architecture of the fuzzy inference system consists of 4 parts: fuzzifier, rules, inference, and defuzzifier. A crisp set of input data are gathered and converted to a fuzzy set using fuzzy linguistic variable, fuzzy linguistic terms, and membership function. This step is known as fuzzification. Afterwards, an inference is made based on a set of rules And lastly, the resulting fuzzy output is mapped to a crisp output using the membership function in the defuzzification sets. So we start with a crisp input, and throughout the fuzzy architecture, we use fuzzy sets, and again the output is a crisp value.